So in this video, we're going to talk about pressure, volume, temperature, and the number of particles. This is known as PVTn. So PVTn problems are used to show the relationship between gas laws. So if you remember, we've gone over 4 gas laws. They include Boyle's law, which shows the relationship between pressure and volume, Avogadro's law, which shows the relationship between pressure and the number of particles, Charles's law, which represents volume and temperature relationship, Guy-Lossic's law, which represents the pressure and temperature relationship. So, in order to do our PVTn problems, we're going to use IFE charts, or initial final effect charts. So here we have our IFE, but we know we're representing our gas relationship. So here we have P, V, T, and N. So what you're going to do when you read your word problem, you're going to fill in your initial variables here. Then you would put your final variables here, and your effect, which will be represented by arrows, will go right here. So we're going to try some out. So the steps for using the IFE chart: first, you must start with the given variables. Then you must identify the relationship. So is it Boyle's law, is it Avogadro's law, is it Charles's law, or is it Guy-Lossic's law? So what you're going to do next is determine the effect, and that's by using the up or down arrow. 4, you're going to solve for the missing F, or the final variable, or variable. Sometimes you have to solve for more than one. Always convert your T, which represents temperature, to Kelvin, which is going to be 273. So whatever the problem gives you for your temperature in Celsius, you're going to add 273 to it. Diagram the final condition. So after you've solved and you've gotten your answer, you're then going to do a particle diagram to show your final conditions. So we have our first problem here. It says a sample of gas occupies 150 milliliters at 25 degrees Celsius. What is its volume when the temperature is increased to 50 degrees Celsius? So here you get opportunities to start annotating or breaking down and analyzing word problems. So the sample of gas occupies the volume of 150 milliliters. So we know milliliters does measure volume. So what we're going to do is, in our chart, fill in 150 for initial volume. And it says at 25 degrees Celsius, but remember we must convert temperature from Celsius to Kelvin, so 25 plus 273 gives you 298. That's going to be our initial temperature. And then it says what is going to be the volume. So we know we're looking for X, so we can place an X right here. When the temperature is going to be increased to 50 degrees Celsius, so there should be an increase in the temperature. And let's check. 50 plus 273 gives us 323 degrees Kelvin. So that is an increase in the temperature. So we're going to put 323 right here. So we notice that 323 is bigger than 298. So there's going to be an up arrow right here for the effect. So the relationship between volume and temperature is Charles's law. So we know that those two variables, volume and temperature, have a directly proportional relationship. So if temperature increases, then volume should also increase. So we're going to be looking for a number that's going to cause an increase in the volume. So we're going to set up a conversion or a proportion to solve this. So we're going to start with what's given, which is 150 milliliters, because we also want to solve for milliliters. And then remember, when you're setting up proportions and you want your answer to increase, the bigger number is going to be the numerator, and the smaller number is going to go at the bottom as the denominator. And if you wanted the inverse, if you wanted to decrease your answer to become a smaller number, then what you would do is put your big number at the bottom as the denominator, and the small number would be your numerator. So here we want our answer to increase, so we should have our big number up top. So 323 is going to be the numerator, and 298 is going to be our denominator. So we're going to multiply across and divide. So 150 times 323 divided by 298. And remember, Kelvin is going to cancel. We're just going to be left with milliliters, which is what we want our answer in. So you should get 162.5 milliliters. And notice that 162.5 milliliters is greater than 150 milliliters. So you know that you did your problem correctly. what you could always do, because we don't need to do anything with pressure and the number of particles, is mark it out, and that way you know from the beginning you don't have to worry about it. It only talks about volume and temperature in this problem. So with our particle diagram, we have our initial, remember volume is green, so this is our volume as the perimeter. Final, we have our volume. You notice that the volume here is smaller than the volume is here. So 150 milliliters, 162.5 milliliters, and then a temperature of 298 and 323 here. And what we're going to do for our particles to represent temperature is put whooshies on them. So whooshies are these little lines. The lines help represent the speed of the particles. Speed is a direct relationship to temperature. So the higher the temperature, the faster the particles move. The slower the particles move, the lower the temperature. So here, now that our temperature was at 298, we need to show that in the final diagram that the particles have started to move faster because the temperature is increased. So we're going to increase the amount of whooshies. So here we only have one whooshie for each particle. Here we're going to have two. So our particles have sped up in the final diagram because the temperature has increased. So in the second problem, Sam's bike tire contains 15 units of air particles and has a volume of 160 milliliters. Under these conditions, the pressure reads 13 psi, which is your pressure unit here, and the tire develops a leak. Now it contains 10 units of air and has contracted to the volume of 150 milliliters. What would the pressure be now? So again, we need to annotate our text. So pressure is going to be represented by blue, volume by green. It doesn't talk about temperature at all so far in this problem, so we're going to go ahead and mark through that because we don't have to worry about temperature. And then number of particles is going to be represented by N, and it talks about the number of particles, specifically air particles, in the units of the actual word unit. So we're going to start filling in our chart. We have 15 units of air particles to start with. And then it says a volume of 160 milliliters. So we have 160 milliliters to start off with. And then it says under these conditions, the pressure reads 13 psi. So we know we have initial pressure of 13 psi. So then it says the tire develops a leak. So you know if it's a leak, there are going to be air particles leaving. So notice that we have 10 units of air particles for the final amount. And then it says the volume has now contracted to 150 milliliters. So our volume has decreased. And we're looking for pressure because it says what will be the pressure. So if underline pressure, that's what's going to go here. So we're going to put an X here. So now we need to talk about the effects. So we know that the relationship between volume and pressure is Boyle's law, and they should have an inverse proportional relationship. So that means when one is going up, the other should be going down, or vice versa. If one's going down, the other should be going up. So now we know that volume is going down, pressure should be going up. But if we're looking here trying to figure out the pressure, we really need to worry about the number of particles. So remember, the number of particles and pressure have a direct relationship. So that means if the number of particles has decreased, that means the pressure should also decrease. So we have two different arrows here, and I tried to write which arrow represents which variable for you so you can see that. So just like we have it represented here, we need to also show an equation and solve so that we can find pressure using all of our variables. So remember, we talked about pressure and volume having a indirect relationship. So what that means is when one increases, the other decreases, so we have to set it up so that will happen. So remember, we want to decrease, so the smaller number would go up top and the bigger number at the bottom. And then we actually want the opposite to happen for the number of particles. So the bigger number is going to go up top and the small number is going to go up bottom. Towards the bottom, we're going to multiply across and then multiply the bottom and divide. So 13 psi multiplied by 160 milliliters multiplied by 10 units. And then we have 150 milliliters and 15 units here. Milliliters is going to cancel. Units are going to cancel. So when you multiply, cross, and divide, you're going to end up with 9.2 psi. Then you want to go back and figure out, is 9.2 psi less than 13? Because we're focusing on the relationship between pressure and the number of particles. So because the number of particles decrease, we want the pressure to also decrease. 9.2 is less than 13 psi. So what does that look like in our particle diagram? So here we had a greater volume. We have a smaller volume here, or less volume. The number of particles, you can count 15 for this one and 10 for this one. And you notice the spacing, which is where the pressure comes in. The more particles you have, the less space that they have. The same thing is reflected here. So you have more particles here, they were able to kind of space out more. And if you have less particles here, they're not able to space out as more. And I tried to show you this by, there's no specific pattern in the particles over here. There is a specific pattern here because the pressure effect has caused them to kind of stay in the same spot. The more you practice, the easier this will get. Good luck.